Hello, welcome. In this lecture, we would like to understand the industrial processes of fats and oils. Our focus area is the key industrial processes that are used to refine, modify, and stabilize fats and oils. And the key applications here is in cooking oils, margarine, shortening, and bakery fats. The processes we are going to look at specifically, we have refining, hydrogenation, interesterification, frying chemistry, and oil behavior. Refining of oils and fats. From the way you hear the word refining is to make it better. Refining involves removal of undesirable substances from crude oil. In this process, we see impurities being removed, and one of these is the cellular debris, such as the proteins and carbohydrates, the free fatty acids, for example, 5% in palm oil, phospholipids, pigments, odorous compounds like the aldehydes and ketones. We have some key processes involved in refining. The first is the steam refining, and this occurs by injecting steam through hot oil and a vacuum. It removes odors and free fatty acids. Then also the alkali refining. It treats oil with the sodium hydroxide or sodium carbonate. And also the same process that occurs in saponification. Free fatty acids reacting with sodium hydroxide, leading to formation of soap separated by centrifugation. And the other process is bleaching. This involves removal of pigments via adsorption, for example, fuller's earth and activated charcoal. Then steam deodorization removes odor compounds using low pressure steam, and this is done with heated oil to up to a temperature of 425 to 475 degrees Fahrenheit, and then involves also rapid cooling. Hydrogenation, as we earlier on said, refers to addition of hydrogen to unsaturated fatty acids. And the objective here is to convert the oils into semi-solid fats such as margarine and improve oxidative stability. The process involves mixing oil with a catalyst, that is nickel, and heating it to a temperature of 140 to 225 degrees Celsius, and then adding hydrogen under pressure up to 60, and then monitor via refractive index, and finally filter to remove the catalyst after the reaction. The other process is interesterification. The purpose of this process is modify melting properties and plasticity, and the process involves rearranging fatty acids on the glycerol backbone, creating a random distribution of fatty acids, and this is useful for customizing functional properties of fats. The types of reactions involved in interesterification, we have one, acidolysis, that involves an ester and an acid, alcoholysis involving an ester and alcohol, and then transesterification involving an ester and an ester, which is the most relevant in food fats. Randomization versus interesterification. Interesterification is a planned arrangement, but randomization occurs just randomly. There is no plan. Randomization or the random shuffling creates new tags, triacylglycerols. For example, a fat with A and B fatty acids can have 8 combinations possible, resulting in improved consistency, melting behavior, enhanced baking, and also frying performance. Thank you. These are the basic processes involved in the refining of fats and oils.